It diverges, right? What about any multiple of 1 over x?
1 over 2x.
Ah, 1 over 2x. So if you did this right here, if you did the integral from 1 to infinity of 1 over 2x, how does that compare?
It's a little bit, it's always like, when x is greater than 1, it's always
Exactly.
bigger than.
Finite doesn't matter, but for the infinity of terms, as x gets bigger than 1, what happens here? 2x is always going to be greater than 1 over x, right? So is this true right here? Is it always less than right here? After x equals 1, right? It's equal, and then that's just true. But what do we know this is equal to? This is 1/2 the integral from 1 to infinity of 1 over x. And what do we know about this? This is divergent. So we have just shown that that integral is greater than something that's divergent. Done. I'm trying to show you the quickest method as possible. Are there many other options? Absolutely. Definitely. We're only covering the quick options right now. Yes, Yana?
Why in the textbook the answer is does not converge?
Yeah, it does not converge, so it diverges. Does not converge is the same thing as divergent.
Because sometimes they write one thing, sometimes they write divergent.
I would have to see all the analysis. Not to my knowledge, no. Do you know how answer keys are usually generated for textbooks like this, by the way? 8 to 5 of 1 over, or we can, I'm going to just write this a little differently. T to the what? T plus 1 to the negative 2 dt. Are we okay with that? Let's see how far we can go with this. Can someone integrate that for me? What's the integral of that? It's going to be the limit as a goes to negative 1. What's the integral of that? Negative t plus 1 to the what? To the negative 1, like this. And it's from a to what? 5. So it's the limit as a goes to negative 1 of negative 1 over t plus 1 from a to what? 5. So that's the limit as a goes to negative 1 of negative 1 over what? 6 plus 1 over a plus 1. Is that correct? Is that correct? Are we good so far? We've now broken it down into something that theoretically is digestible automatically. Well, that stays the same. That's just negative 1/6. So what are we really interested in doing here? What is the limit as a goes to negative 1 of 1 over a plus 1? What happens? What does that do? As you approach negative 1, oh, and by the way, we need to put to be totally correct here, we need to put a side on this, right? We're going from negative 1 to 5. So what side of negative 1 are we approaching from? The right-hand side or the left-hand side of negative 1? To the right. Why from the right, X?
Because the limit is to the right.
Yeah, you're going from negative 1 to 5, right? Negative 1 to 5 is to the right. So you're approaching negative 1 from the right. So you have to put this little plus sign. Do you remember sidedness on limits, everybody? Kinda. You're approaching negative 1 from the right. Negative 1 from the right. So if you approach negative 1 from the right on this one, what number is to the right of negative 1, but really close to negative 1? Like negative 0.9999999. So what is this going to be? Well, it's going to be 1 over. Is it going to be positive or negative? It's going to be positive, but it's going to be really, really what? Small. What's 1 over a positive, really small number? What? Infinity, or positive infinity. So we've just evaluated this. It is divergent. It does not converge. It is divergent. It does not converge. There are other ways. There are multiple paths you can make here, everybody. Do you want to see the fun, shorter way? Honestly, this is what I would have done, but the shorter way, you can use U substitution right off the bat. So were you talking about third person? You said that's what Josh did? What are we going to let U equal, KU, to make this nice?
T plus 1.
Yeah, t plus 1, right? So du is equal to dt. So if we do that, what do the limits of integration become?
It becomes, wait. It should be 0 to 6.
Yeah, 0 to 6, exactly. It becomes 0 to 6, right? So you end up with a slightly different thing here, which is something that does diverge. Like if you look in the answer key in this, it just says, this diverges. Congratulations. You still need to do some work, but it allows you to do it without doing the plus 1. It's fine. Okay, let me see. So this one's fun. Let's do it by comparison. What's the thing in there that we don't like, theoretically? Well, we don't like the square root, but that's, you can't quite do, you got to keep that there. We don't like the plus 1, right? We just don't like that thing, right? So if we got rid of that plus 1, we've made the denominator smaller. So therefore, the whole thing has gotten what? So this is less than what? The integral from 2 to infinity of what? D theta over theta cubed to the square root of theta cubed, right? Square rooting is what power, Lydia? 1/2. So it's cubed to the 1/2. So if you write this out, it's going to be 2 to infinity of d theta over what? Theta to the what? 3/2. What type of p series would this be?
Well, p is greater than 1.
Ah, so what does this do? This converges. You can also check this by actually integrating it out if you'd like. You can integrate this out. So you know that this what? This converges. Why? Since 3/2 is greater than 1, that would be totally fine for you to write on a test for me. You've identified the key thing that has to be greater than 1. The terms get smaller and they are positive, so you can use this integral test. So if that converges, what does this have to do? Converges since less than converges. That would be enough. I'm okay with that. X times plus C times equals what? Are you okay with what I've done so far? Do not multiply this out. I'm letting you do the terrible, ugly method, okay? What happens, question, if I plug in 0 for x? What happens? Tell me what happens when I plug in 0 for x at this point. If I plug in x is 0, what happens? End up with a times 2 times -1 equals what?
B times 0.
Yep. Equals what? Keep going. Equals what? 3. So what does a have to be? 3 over? Oh, that's so nice. Okay, what's another number I could plug in? -2. If I did that, if I plugged in -2, I'd end up with b times -2 times what? Equals what? Careful. Equals? Equals what? -1. So what does b equal? 1/6. Oh, so nice.
Wait, I think there's a negative.
Where's the negative?
Negative sign because negative.
Don't I plug in -2 right there and I plug in -2 right there? Oh, it turns positive, so there's a negative sign right here. You're absolutely right. Thank you. So what do I plug in now? X equals what?
Positive 1.
+1. If I plug in 1, what do I end up with? C times 1 times 3 is equal to? 5. So C is equal to 5/3. So now, can we rewrite this integral right here? Can we rewrite it? Sure can. How many integrals do I have? 3 of them. I'm going to factor it out as well. So I have -3 over 2 times the integral of 1 over x dx plus what? Or minus what? Minus 1/6, right? Minus 1/6 times the integral of 1 over x plus 2 dx plus 5/3 integral of what? 1 over x minus 1 dx. Are those all things that you should be able to integrate really, really easily? What's the integral of 1 over x? Ln absolute value of x. Integral of x plus 2. Oh, ln of x plus 2. Oh, nice. We just took something that would have been very hard to undo, broke it apart into 3 tiny pieces. I found out recently last year that saying wanla is like not a good way to say it. Because that doesn't mean like you're dead.
Yeah.
Yeah, right, exactly. I'd be like very, very happily asked like, ni wanla? And the kids are like, no? Well, you might have tried, who tried that? Who tried x plus 1 squared? Did anybody try that? You did, you're like, yeah! And then you're like, no! So what does this equal? What does this equal? What does x plus 1 squared equal? I'm giving you something crucial here. It's x squared plus what? 2x plus 1. Do you agree with that? Okay. If I did this, x plus 1 squared equals, you agree that this is true, x squared plus 2x plus 1 is still true? I just made some space. What am I going to add to both sides? Is that the same thing? Is that the same exact thing? Have we changed anything about it? Have we changed anything about it? So that's one hint That's one hint I could give you, right?
Then it's not tangent.
So yeah, you have to be really, really, really careful about this. So what does this equal right here? It's the integral of 1 over what? X plus 1 squared plus 1 dx, right? And we're almost perfectly to arctangent. Let's just do one more thing because I want to do every last little bit here. I know, it's very important to me. So what u substitution should I do? Well, I'm just going to make u equal to x plus 1. Is that okay?
Yeah.
Du is equal to dx. So now what does this equal? We have the integral of 1 over u squared plus 1 du. What is that integral equal to? Arctan of u plus c, but u is equal to, oh, so it's just going to be tan inverse of. So look at that. All we did was change one little tiny thing, and it went from a partial fraction decomposition, which had an answer that looked like this. We changed one little tiny thing, and look what happened to the answer. Hey! It's kind of cool.